This video is going to look at integrated rate laws and using graphical determination to figure out if it's zero order, first order, or second order. So I'm going to start off with data here. And a lot of times you might see the data like this, where you have time and you have concentration, and you're looking to see, is this zero order, first order, second order? And sometimes you have graphs. So I'm gonna, let's look at the data first. The data, if I see that the time is constant here, so I have 10-second intervals, and then if my concentration also drops at the same rate, so it's linear, so this is a drop of 10, a drop of 10, and so on, that means that the rate is the same for concentration drop all the way through, and it does not matter where I started on the time, it's gonna be the same concentration drop. So this is a zero order process. How we show this on a graph is if I have a concentration of A versus time, it would be linear. Okay, so I would draw a line like that. And so if this is linear for A versus time, then it's zero order. Now, a lot of times on the AP test, they might show a graph like this, and then they'll also say, well, if you don't see this data, but if I have the natural log of A, and then 1 over A. Okay, so if I have natural log of A versus time, and 1 over A versus time, and I graph this out, this one would be something like this usually. And then this one here, 1 over A versus time might be something like, let's see here. If I go like that, okay? So this one usually goes up, but if these are curved, so if curved, we don't want to look at it if it's curved. So that's kind of a signal is if it's not linear, then we don't really want to care about that graph. And the reason why is this. So if you look at the equation sheet, I'll tell you why this is going to be linear. If this is the zero order rate law, so this is the integrated rate law for a zero order reaction. And if this is linear, okay, the way this sets up is A of t is like y. This is the y-axis. And then A naught is the intercept, because that's the starting time. And then this thing here, t is x, okay? So if I were to rearrange this equation, I would see that A of t equals negative kt plus A naught. Okay, this is the same thing as slope-intercept form. So if I have y equals mx plus b, y is like A of t, b is like my intercept, and t is like my x. So if this is linear, that means for this equation here, this is zero order. If the natural log of A was linear, then this one would not be linear. Or if this one was linear, this would not be linear. So only one of these is ever going to be linear, okay? So you got to know if it's A versus time and it's straight, it is zero order. Okay. If curved, ignore. Okay, so now I'm going to go to the next set of data. The next set of data looks like this. So let's say I have time versus A of t, and I can see that these intervals are not the same all the way through. So this is not the same, this is not the same, these are not the same intervals. Okay, but if I take the natural log of all these numbers, and I can see that these are all the same intervals relatively. So this is a negative 0.35 drop. This is about a negative 0.35 drop, 0.35 drop, 0.35 drop. So these are all about the same intervals. So therefore, this graph is going to be linear. So I'm going to show how this works out. So now if I graphed the natural log of A versus time, and I see that this is, oops. Okay, so this is now linear. So if the natural log of A versus time is linear, then this is a first order process. Okay, so you would see that this graph is straight. You would see that the A versus T graph is going to be like this now. So you're going to have some kind of curve on the A versus T. You would also see that 1 over A versus T would be something like this. So this is, so remember, if it's curved, it's not going to be zero order. If this is curved, it's not going to be, this is the second order graph. And so if I see ln of A versus time is linear, first order. And why is that? The integrated rate law for first order process is using a natural log equation. So if I were to say slope intercept form for first order process, y is now the ln of A, and my intercept is now ln of A naught, t is still x. So this is basically your guide to tell you if it's zero order, this is straight. If it's first order, this is straight. And then for the last graph is 1 over A versus T. So I'm not going to do data for that because I couldn't find any data easily. But if I see that 1 over A versus time is linear, so this is linear. So if 1 over A versus time is linear, then it's a second order process. And then the other graphs would be nonlinear. So you would see that A versus time is going to be some kind of curve like this, and ln of A versus time would also be some kind of curve like this. Okay, so as you're doing these problems here, I'm going to show you one problem here that's kind of representative of this. So let's look at a recent AP exam. This is 2019. And you can see that this question says NO2 decomposes and it's a byproduct of combustion, blah, blah, blah. And here are the graphs that show the data. So here's concentration versus time. You can see this is a curve. This is 1 over, so you can tell they don't put them in order, right? They don't put 0 first, second. They're gonna mix them up. So that's one thing to look for is you gotta know which ones go with which. So 1 over NO2, this looks like the most linear one here. Let's look at this one here, ln, this is a curve, okay? So then you would decide, looking at these three graphs and my knowledge on integrated rate laws, what order is the graph? So you have to explain, and it actually tells you second order. And then write the rate law for decomposition. Well, writing the rate law of decomposition is with respect to NO2. You know it's second order, so you gotta make sure it's a second order rate law. Question like 2016, very similar. So as soon as you know what order it is, you can start doing the problem using these equations here. 0 order, first order, second order. Okay, so that is your task. Good luck. I hope that helps.